Hello people, welcome back to my channel. So today in this video we'll be seeing what is tree pruning or pruning essentially in decision trees and why we need to do it and some of the different methods of pruning. So let's begin. So we have the main topic here, that is I've considered that is the reduced error pruning. So it's a kind of variation in the pruning. So before that we need to understand two types of or two methods of pruning. So basically what is pruning is, so pruning is a process of adjusting your decision tree in order to minimize the misclassification error. So in the previous video we saw the kind of techniques like we had for handling the overfitting and underfitting. So in that we saw how the generalization error was minimized and how we classified different instances into some other class labels. So it was a kind of misclassification error. So if you didn't watch that video, so I suggest you to check that video before you watch this one. So that kind of minimalization in the error, that is misclassification of error, needs to be done, or it has to be lowered as much as possible. So that is the main motive of any tree pruning algorithm. So here also our main motto is to minimize the overfitting of the model. So mainly to address or mainly to deal with the overfitting of the model, we have this tree pruning which comes into picture. So we essentially have two techniques in this and one variation of tree pruning. So our first technique or first method is called as the pre-pruning, or it's also called as the early stopping rule. So from the name itself we have something called as early stopping, means we stop the tree growth before it is being completely built, and so you halt the subtree construction at some particular node after checking some measures. So say for example you have this decision tree and so it has got some kind of nodes and some edges and leaves. So subtree can be considered as something like this. So this becomes a subtree in this, or this can be a subtree. So this is a left subtree, this is a right subtree. So you try to halt the subtree construction. So first of all you begin with one particular node, then you just start growing into one particular branch. So one subtree or any of the subtree is halted, or its growth is halted if one particular kind of attribute test condition or some measure is evaluated. So that measure could be some Gini index for splitting, or it could be information gain, means which node has the highest information. So based upon that you do the splitting. So based upon that you just stop the tree growth, and at that instinct whatever your tree would be, that is your decision tree. So that is the main idea of this. So here in this, the tree growth stops prematurely. So before it is being built or before it is being stored into the main memory, it is halted. And so one main advantage of pre-pruning is that it avoids generating overly complex subtrees which overfits the training data. So this was the main cause for overfitting in any training model. So this generally reduces it. So there is one disadvantage also that we'll discuss at the end of this. So this is one technique. So we know that we have our data set divided into n number of rows and n number of columns. Now this table, this will be a relational DBMS. I am not going into much of the DBMS concept. So this is a RDBMS, relational DBMS, and so we have this tuples. So in this you call this as tuples, and these are called as attributes. So columns are called as attributes and row you call that as tuples. Now in order to split the tuple, you just check with the condition at each particular node, and if the splitting just falls below one particular threshold, then we try to decide to prune the tree. So that is the main logic in pre-pruning. Like you have one particular tuple, then one particular tuple represents one particular node here, and if it has to be splitted in some particular condition, then upon the evaluation measure we just check whether it falls below the threshold or not. If it falls below that particular threshold, then we try to prune it. So that is the main logic in pre-pruning. Next type of method or pruning method we have is called as the post pruning, means pruning after the tree is built. So it grows the decision tree entirely. So till whatever length or till whatever depth you want to design or you want to grow, you can grow till that point, and you just trim the nodes of a tree in bottom up fashion. So this is moreover like if you have grown a beard, so and if it just grows out, so what you do, you just take the trimmer and you just trim from the bottom up fashion. So similar kind of thing is there in decision tree. You just bottom in a bottom fashion, you just trim the decision tree, and what is done is basically the node that is there at each particular level, it is replaced with the help of a leaf node. And even after the trimming, if the error improves or there is significant increase in the error, then what we do is we just trim the subtree, or we just replace the subtree with a leaf node. So this is leaf node. So we'll just consider one example here. So this is how the post pruning is. Now there is one comparison between pre-pruning and post-pruning. Now in terms of efficiency, this is faster as compared to post-pruning, because before the tree is built, you are just prematurely halting the tree growth, and here you have to grow the tree at some level, and then after that you decide which nodes to be trimmed or which node has to be replaced with the leaf node. So that kind of decision is done here, and so you have one kind of interaction effect here. So interaction effect is basically, if tomorrow one attribute comes and it has to be fitted into the decision tree, so that will be checked only in post pruning whether it has to be pruned or not. So that facility you don't get in pre pruning. So why? Because it's prematurely stopped at the early growing stage. So it has one interaction effect. So this is one important point regarding post pruning. Next we talk about our main topic of today, that is we have the reduced error pruning, that is called as the REP. So in this basically what we have the data set, we divide into training set, we have the test set, and so in reduced error pruning we generate a pruning set. So that is holding out by available instances. So the instance or the training instance which you have, so from that we just keep aside some of the training instances and we just put it into a pruning set. So this red table what you can see is called as a pruning set. So it has some kind of instances and the classes assigned and some of the rows and columns like in relational DBMS, and so it provides estimate of error rate on future instances than the training data. So the pruning set is not used to build the tree. Like the training data was used to build the decision tree, but pruning set is not used to build the decision tree, but it is just used to check the error estimate and it's compared against the training data. Means first you have some training errors which will cause you underfitting, something like that. So a pruning set just give an estimate, because it will just compare whether how much error is there or how much increase in error is caused in training error as well as in the pruning set error. So this is the main motive of having a pruning set. Now we just solve with an example of the above discussed scenarios and all. So we have this decision tree. So consider this decision tree having different number of nodes, and then you have the leaf nodes. Now for performing reduced error pruning, there is one condition. So that condition is basically if your error of parent, means error of the parent node, is less than the error of child node. Means if the error of parent node is less than child node, then you need to prune, else don't prune. So it's simple as that. So our main motive is child nodes or child leaf nodes should not have any errors, but the parent can contain n number of errors. Means if the error of parent is 1 and if child error is containing 2, then this condition evaluates to be true and then we prune. So let's see with the help of an example. So we have some of the nodes here, and so each of the node is just represented with the help of some labels. So we have 10, 11, 9, 1, 2, 3, 6, 4, 5, 7. So these are the attribute test condition, that is if x is equal to 0 and it just jumps from this node to this node. Then we have x is equal to 1, z is equal to 0, z is equal to 1, y is equal to 0, y is equal to 1, and so on. Now we just estimate, so we can see that is in bracket, so that is basically the error which it has got. So this error, if you compare it with the child, so we have at the child one error, but parent has got no error. So if we go with this rule or this condition for reduced error pruning, then this should ideally become a leaf node. So a node, so you can see here a node, trim the nodes in bottom up fashion and replace the node by leaf. So this part, so this part becomes a leaf node. So whatever was there here, this becomes a leaf node. Similarly, if you go here, that is again you have the same condition, that is parent had 0 error but child had 1 error. So what I do is I just remove this and this becomes my leaf node, and I just trim this. So now you can see the decision tree which was there earlier, which was overfitted, now it has been reduced into smaller size. Now you just check again. So now you have this part. If you consider this subtree, the error of parent is 1 but child nodes are purer, means they don't have any error, so we just keep it as it is. Similarly here you have the child nodes, it has 2 errors but the parent has only 1 error. So similarly we just replace this node with the help of a leaf node and we just remove this. So this is our final decision tree after reduced error pruning. So this decision tree won't be overfitted into the model if you train the data. So well, that was all regarding the reduced error pruning in decision tree. So hope you guys enjoyed this video and got educated from this video. Please do like, share, comment, and if you are new to this channel, please consider subscribing. Thank you very much for watching this video.